Welcome to the last video on this session on mathematical inductions. As we said, mathematical induction just involves two stages. The first stage is just to test the base case, and the second stage is how to prove the proving stage. And we said the proving stage, it doesn't have a recipe. It always depends on the question. In this video, I have solved about 5 different type of questions under mathematical inductions. They are endless. When it comes to mathematical inductions, the questions are endless. You need to search for more and do practice on your own, and that will broaden your knowledge on mathematical induction. But this is just to give you the basics and the foundation, and to re-echo that at the proving stage there is no a lay down recipe that you need to follow. It all depends on the particular question. So your mathematics skills must be well sharpened. Do not forget to subscribe to my channel for more of such videos. Now let's delve into the question. We have to use the principle of mathematical induction to verify that for n, any positive integer 6 raised to the power n minus 1 is divisible by 5. So we'll test the base case. When n is equal to 1, we'll have 6 raised to the power n 1 minus 1 is equal to this raised to the power 1 minus 1, and then that will give us 6 minus 1, and that is 5. So 5 is indeed divisible by what? 5. Then let's set our inductive hypothesis. When n is equal to k, that will be 6 raised to the power k minus 1. And since this is a hypothesis, we don't argue, we accept that it's divisible. It's divisible by 5. And how do we write it using mathematical equation? And that will be 6 raised to the power k minus 1 is equal to 5x, where x is a natural number. A natural number. So if n is equal to k is true, then we need to prove that when n is equal to k plus 1 is also true for this proposition. So when n is equal to k plus 1, we are going to have 6 raised to the power k plus 1 minus 1. So we need to prove that this is indeed true by using our inductive hypothesis. So let's use the inductive hypothesis. The hypothesis says that 6 to the power k minus 1 is equal to 5x, where x is a natural number. We can remove the 1 from that side and send it to the right hand side. We can plus. Let's multiply through by 6. So 6 times 6k, 6 is the power k. Then 6 multiplying 5x plus 1. The left hand side, we can use the laws of indices to written as 6 raised to the power k plus 1 is equal to 30x plus 6. We can subtract 1 from each side of the equation. Minus 1 is equal to 30x plus 6 minus 1. So we have 6 raised to the power k plus 1 minus 1 is equal to 30x plus 5. We can factorize 5 out from this expression. So we'll have 6x plus 1. Good. So we have arrived at the expression we have to prove. You can see. So this expression is what we are looking for. We have arrived at that. And if the right hand side is divisible by 5, then the left hand side will also be divisible by 5. And since x is a natural number, it holds that the bracket will always result in a natural number. And once the bracket is a natural number times 5 is a multiple of 5. So hence, the expression 6 to the power k plus 1 minus 1 is divisible by 5. So the proposition is indeed true for all natural numbers of n greater or equal to 1. Thank you very much for watching this intensive video on mathematical induction. Do not forget to subscribe to my channel for such wonderful videos in subsequent blogs. Goodbye.